Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that find the general solution of the following second order linear differential equations. So these are 5 solutions. So now we'll start with the first one. The square y over the x square plus 5 dy over the x plus 4y is equal to 0. So now, here's the first one. So this kind of equations, before you solve them, you have to make a substitution. You have to make substitutions. Now, you will substitute the square y over the x square with m raised to the power of 2. Now, you will substitute the square y over the x square with m square. That is m raised to the power of 2. Then, wherever you see the y over the x, you substitute it with m raised to the power of 1. Then, wherever you see y, you substitute it with m raised to the power of 0. So, we'll solve it like this. It will be m squared plus 5m raised to the power of 1 plus 4m raised to the power of 0 is equal to 0. So I'm doing normally I don't write m raised to the power of 1 and m raised to the power of 0. I just write 5m plus 4. But since I'm trying to show you how the substitution is done, that's why I'm writing this. So this, the square y over the x square, you substitute it with m square. This, the y over the x, substitute it with m. And this y, you substitute it with m raised to the power of 0, which is 1. So this equation now becomes m squared plus 5m plus 4 is equal to 0. Then we will solve this equation. It's a quadratic equation. You can use the quadratic formula to solve it, or you can use factorization method, or any other method you want to use. Now, the values of m that we'll get from this equation is called auxiliary roots. And this equation is called an auxiliary equation. This is a quadratic equation in terms of m. It's called the auxiliary equation. And the values of m is known as the auxiliary roots. So the roots of this auxiliary equation is known as the auxiliary roots. And these roots are known as auxiliary roots. And the solution of this equation depends depends on the roots of this auxiliary equation. That means the solution of this equation depends on the auxiliary roots. And they are different. Each auxiliary root determines the kind of solution you are going to write. So in this question, each of the solutions is different. So you are going to see how you write each solution depending on the auxiliary roots you get. So now we will factorize this. To factorize this, the product of this and this is what? It's 4m squared. We are using factorization method. 4m squared. 4m squared. So we'll find two terms that the product will give us this, and the sum will give us this. So it will be 4m and m. So this equation can be written as m squared plus 4m plus m plus 4 is equal to 0. So now this becomes m plus 4 plus 1 m plus 4 is equal to 0. So this becomes m plus 4 m plus 1 is equal to 0. So now we can equate these two to 0. M plus 4 equals to 0, or m plus 1 equals to 0. So m will be equals to -4, or m is equal to -1. So these are the two answers. So these equations, these two auxiliary roots are real and distinct. So since they are real and distinct, So these two auxiliary roots, they are real and distinct. So since the auxiliary roots are real and distinct, the general solution now becomes y is equals to a exponential m1x plus b exponential m2x. So this is the general solution of this equation. So now we will substitute m1 and m2. So you can take any of this m as m1 and you can take any of them as m2. It's still correct. If I put minus 4x here and minus x here is correct, it's the same thing. If I also put the reverse, also correct. So we can say that y is equals to a exponential what? Minus 4x plus b exponential minus x. If you put minus x here or minus 4x here, any one is correct. So any order is correct. So this is the general solution of this equation. We have finished the first one. So now here is the second one. In the same way as we did the first one, this one will be m squared plus 4m plus 4 is equals to 0. So this one is the auxiliary equation. Let me write it here. Auxiliary equation. This is the auxiliary equation. This one, the one in terms of m, is called the auxiliary equation. Then the roots is called the auxiliary root. Now let's find the auxiliary roots. So this one, by merging, this is 4m squared. 2m will multiply to give us 4m squared. And 2m plus 2m is 4m. So m squared plus 2m plus 2m plus 4 is equal to 0. So this becomes m plus 2 plus 2 m plus 2 is equal to 0. So this becomes m plus 2 m plus 2 equals to 0. So now from here you can know that m plus 2 is equal to 0 or m plus 2 is equal to 0. So m will be equal to minus 2 or m is equal to minus 2. So this one, you can say that m is equal to minus 2 twice. So this is the auxiliary root, is minus 2 twice. And you know that since, that means this auxiliary root is real and equal. So since this auxiliary root is real and equal, so this is real and equal auxiliary root. So real and equal auxiliary root. The last one was real and distinct. This one is real and equal. Real and equal. So the general way we are going to represent is given by, so the general solution is now given by y is equals to a plus bx exponential mx. So now the general solution is given by y is equals to a plus bx exponential mx. This is called the general solution. Let me write it. This is called the general solution. This also is called the general solution here. General solution. So I think subsequently I won't be writing I won't be writing general solution and the auxiliary equation. I've showed you that this is the auxiliary equation, this one. Also, likewise here, you know the auxiliary equation now, and you know the auxiliary roots, and you know this is the general solution. So now, the only one I'll be writing is this one, whether it's real or equal or otherwise. So now, we'll substitute m here, since it's the same. So the general solution is now y is equals to a plus bx exponential minus 2x. So this is the final answer. This is the general solution and the final answer. Know that because these roots are real and equal, this is the general solution for roots that are real and equal. Then the last one we did is the general solution for real and distinct roots. So if you solve any auxiliary root, if you solve any auxiliary equation and it gives you real and distinct roots, you use this general solution. And if you solve any one that gives you real and equal roots, you use this general solution. So there are different forms for different answers. So that's why I said that the general solution depends on the auxiliary roots you get, on the kind of auxiliary roots you get after solving your auxiliary equation. So now let's move to the third one. So now here's the third one. In the same way, m squared plus 4m plus 9 is equals to 0. So this kind of quadratic equation, you can't solve it using factorization method. You have to use the quadratic formula. Because this will be 9m squared. What will times to give you 9m squared and add to give you 4m? It's hard for you to think of any value for that. So you have to use quadratic formula. You can't use factorization method. Let's use the quadratic formula. M will be equal to minus b plus minus b squared minus 4ac all over 2a. This is the quadratic formula. So you know that a is the coefficient of m squared, b is the coefficient of m, and c is 9. So we'll substitute it into it to be minus b is 4 minus 4 plus minus 4 squared minus 4 times 1. A is 1, the coefficient of m squared, times c is this term, which is 9 over 2 times 1. So let me find the bracket, the square root term. 4 squared minus 4 times 1 times 9. You see it's giving us error. That means I'm sure it's an imaginary number. This will be 4 times 9 is what? Is 36. So it will be, and this is 16. So 16 minus 36 is what? Is minus 20, you see. So this will give us minus 4 plus minus root of minus 20 over 2. So 20 can be expressed in terms of 4 times 5. So, and this one will be minus 4. We'll divide both sides by 2, minus 4 over 2, plus minus. So this will be root of minus 4 times 5 over 2. So this becomes minus 2 plus minus. We will now separate this. The root of 4 is what? Is 2. So I'll bring out 2. Because this thing is the same thing as root of. But since I'll bring out 2, I'll take the minus to 5. So it will be, I'll find the root of 4. Root of 4 is what? Is 2. I'll bring out 2. So 2 and 2 will cancel this one. So this 2 has gone. Remaining root of minus 5. Because you know that this is the same thing as root of 4 times root of minus 5. So I found the root of 4, which is 2. So 2 will cancel 2. So then it remains root of minus 5. So now you know that the root of this root of minus 5 is the same thing as root of minus 1 times root of 5. So what is root of minus 1? It is I. So this will be negative 2 plus minus I root of 5. So this is m is equals to this. M is equals to this. Now this can be expressed in two ways. So m will be equal to minus 2 plus I root of 5, or m will be equals to minus 2 minus I root of 5. So these are the two values for m. So this is the value for m. And since your roots, your auxiliary roots are complex numbers, so these are complex auxiliary roots. Complex auxiliary roots. So now the way of solving complex auxiliary roots, the general solution is given by y is equals to that's general solution for when for complex auxiliary roots. So the general solution is given by y is equals to c cos bx plus d sine bx, whole bracket e exponential ax. That is e is exponential, so it's this exponential ax. So this is the general solution for complex auxiliary roots. And you know that where a and b can be gotten from this, the general form of this is equals to what? A plus minus ib. This is the general form of this. So where from this, if you relate these two terms, you can know that a will be equals to minus 2 and b is equals to root of 5. So from here you substitute a. Your a here is what is minus 2, and your b is what? Root of 5. So you can say that a is equals to what? Minus 2. B is equals to what? Root of 5. So your a is minus 2 and b is root of 5. So now we can write the general equation. So now y will be equals to what? C cos, what's b? B is root of 5. Root of 5x plus d sine root of 5x exponential what was a? Minus 2 minus 2x. So the final answer for this part, for the third one, is y is equals to c, is y is equals to open bracket c cos root of 5x plus d sine root of 5x close bracket exponential minus 2x. So this is the final answer for c. So this is the final answer for the third one. Let's move to the fourth one. Now here's the fourth one. So we'll substitute. Here will be m squared plus what? There's no dy over the x here, so there's no m. That means here will be 16m raised to the power of 0, which is 16 equals to 0. Because y is m raised to the power of 0. Y is usually substituted to m. Is usually substituted with m. Y is usually substituted with m raised to the power of 0. And there's no dy over the x here. So these are the only two terms. So this becomes what? M squared plus 4 squared is equals to 0. So now, this m squared plus 4 squared is given by m plus 4i, m minus 4i is equals to 0. Because a squared plus b squared is equals to a plus bi a minus bi. This is because when this one, normally is, if it were a square minus b square, it would be a minus b, a plus b. But this is plus. So this plus, but this is plus. The only way we can get this plus is when b square, bi, when bi multiplies bi, you will get negative b square. And minus times minus is what is plus. So that's why we have to put this complex number I. It helps so that this one becomes positive. So this is it. Then you equate it. M plus 4i equals to 0, or m minus 4i is equals to 0. So this becomes m is equals to 4i, negative 4i, or this m is equals to negative 4i, or m is equals to 4i. So these are the two auxiliary roots. Now you know that this equation is of this form: the square y over dx square plus n square y is equals to 0. This equation is of this form, where you know that n will be 4. So this equation, the square y over dx square plus 16, this 16 will be here. If you want to express it in form of this way, if you want to express this equation in form of this, it will be plus 4 square y. So this equation is in the form of this equation. And it is stated that when equation is of this form, the general solution will be y is equals to what? A cos nx plus b sin nx. This is the general solution. This is the general solution for any equation of this form. So, and this is in this form. So therefore, our general solution for this one will be what? Y is equals to a n. You know that n, obviously n is 4, because to get 16 you get 4 square. So n will be 4. So 4a cos 4x plus b sin 4x. So this is the general solution for the question for number 4. And any one you get in this form, this is the general solution. So this is the 5th one. You can obviously see that this one is in this form: the square y over the x square minus n square y is equals to 0. So this equation is of this form. So therefore, the general solution will be y is equals to, this is y is equals to c cos nx plus d sin nx. This, instead of cos, this is cos. This is now cos, and this is sin. Hyperbolic cosine and hyperbolic sine. This is c cos nx plus d sin nx. So now let's solve this. This becomes m square minus 3 is equals to 0. Now to make both sides square, we have to, what will we square to give us 3? Is root of 3. So it will be m square minus root of 3 square is equals to 0, because this square is also 3. So now we will use the normal relation a minus b, a plus b. So now this becomes m minus root of 3, m plus root of 3 equals to 0, since it's m square minus root 3 square. So this is m minus root of 3, m plus root of 3. So it will be m minus root of 3 is equals to 0, or m plus root of 3 is equals to 0. So m is equals to root of 3, or m is equals to negative root of 3. So now we can express it. The general solution now becomes y is equals to what? This one, c cos, you know n is root of 3 from the equation, from this. from this. The root of 3 square will give us 3. So n is root of 3. So this will be root of 3. N is root of 3. So root of 3 x plus d shine root of 3x. So this is the general solution of this fifth question. So this is the general solution of the fifth question. What I want you to know is that each second order linear differential equation has its own auxiliary equation and will give you its own auxiliary root. So depending on those roots, that's how you get the general solution. And each auxiliary root has its own general solution. So I want you to be conversant with all those solutions. If it's complex, you know the one to apply. If it's real and distinct, real and equal, so you have to know all these ones, all the general solutions for each auxiliary root. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.